Beakers, and the purpose of which is just to show you this is kind of a crude method of detecting pH. It's just using a color chart. Some of you said you've already done this, and you do it. Yeah, in fact, second year chemistry AP years we go down to the pool and they show us all the chemistry involved in the pool, and there's a lot of chemistry. And one of the tests that they do is a pH test, among some other tests, to make sure that everything's balanced. And the pH of the pool is like a little over 7. It has to fall within a pretty narrow range. Now, if you look at this, all this has is red is 4, and purple is 10, and then there's a few in between, but it's not that accurate. It's something called a universal indicator solution. So just to give us two extremes, what I thought I would do is put a strong acid in one, and then we'd put a strong base in another. So just pour a little here, and a little. This is the acid, this will be the base, so we can see the two extremes. I'm going to put a little water with this to dilute that, because it's a really strong base.
Now, what are the two compounds?
One is a hydrochloric acid, and the other is sodium hydroxide. So there's the two heavy hitters in acid-base chemistry. This would be your acid here. I'll dilute it down so you can see this is your base. And then basically all we're doing is just going to add a few drops. Go ahead, Seth. I'll listen. This is the acid. Ready?
Pool level chlorine. If it's like a couple levels high, is that more basic or more acidic?
Couple levels high would be too basic.
Okay.
If it's the pH is too high, but that would just be as painful as too acidic.
Yeah.
So you can see the two extremes. We've got a red and a purple, and in between is pH 7, which is this stuff's pH 7. It's a buffer solution, so it holds on 7. And it should be like about what pure water would be. So if I squirt this in, you see we get a green. So you get up and down the line, so to speak. So acid, neutral, basic. So at this point we can try other things and sort of see where they fit. I've got other things out here. Anybody have a preference of what we try first? Okay. Soda. All right. This. Yeah, lemon lime soda. Sprite, 7-Up, Boston brands. This is I think the Walmart one. Right? Where do you think this is going to fall?
No, it's got carbonic acid, so.
Yeah. All right. So you're predicting that the pH would be closer to the acidic. So it should be red, right? Or reddish. Is that what you said? Let's find out. Sure, that's down there. Okay, so that was a good call. Anything else?
The fact that it's caffeine-free affected, like, would it be more acidic if it was had caffeine?
Caffeine's actually basic, but there's so little in there that the acids sort of overtake that.
Coffee is basic then?
Well, coffee's pretty complex. I'm not exactly sure where coffee falls, but the caffeine, if it was just a caffeine pill or something we took, it would be a basic. Because it's got a nitrogen in it, which creates hydroxides, and it's kind of a complex chemistry. But
if we put like an acid in like some type of solution that had 9 times like its volume in water, would that decrease its pH level by 1?
Yeah, you can. Yes, you can dilute it and decrease the pH level. But I think if we diluted this down, it would still maintain. Probably something we might be able to get it to go yellow here, but we'd never get it to go to 7 because you've already added the acid.
All right.
So if you dilute it to 1,000,000 times over, you still got a slight bit of acid in there.
Yeah.
I mean, you might get it to be just about neutral. Okay. Other things? What else do we want? The ethanol? Okay.
Quick pour
right. This is the I'll just put. This is pure pure ethanol. Okay. This would be 100%. This would be, you would not find this in alcoholic beverages. 200 proof, yeah, that's right. So I don't know. I just have a feeling, yeah, it's wait, it turned a little bit yellow. So I have to say that's slightly acidic. Okay, but not strongly acidic, but definitely that's what it's showing. Yeah. Not sure what to say about that.
Shall we see what happens if we put one of the red?
It's got to be about
Red and the purple.
Yeah.
consistent.
Can we put the red and the green?
We'll mix a couple together then, at the end.
Okay.
Let's pick another one or two.
Ammonia.
We've got ammonia, all right? Here's ammonia.
Borax.
All right,
Hey, later.
where do you think ammonia is going to go?
NH3.
Yeah, NH3. Any thoughts on ammonia? I'm just going to dilute it a little. This is just been distilled water.
It will be base.
Okay.
I think it might be,
It's clean.
because this smells pretty bad. And
That's
that's
because it's...
Oh, and
Yeah,
vinegar.
smell does not
And
necessarily...
also if you put vinegar, it dilutes the smell.
It doesn't have OH, but it doesn't... Yeah, ammonia, actually, here we go. This is ammonia. Okay,
Whoa.
you can see. Ammonia is actually a pretty strong, well, relatively strong base. It's not quite as far up as the NaOH, but it definitely is basic. And it has to do with its action in water. Nitrogen compounds are almost always basic, especially if that's the only thing. So. Anything else? What we have here is, this is salicylic acid. Here's that washing soda that we used the other day. This is soap, detergent. Here's bleach, starch,
Borax.
candy.
Oh, let's use candy.
Let's try a candy.
Okay.
Let's try one of the.
How about a midi or a cinnamon or whatever it is? No one ever eats these things. The hotties. We call them hotties because they're cinnamon. But what would you guess for candies?
Acidic.
Acidic.
I don't think. Yeah. You can make basic stuff taste okay with some sugar, but let's find out. It hasn't completely dissolved, but maybe it'll be enough to give us some kind of
It's
pretty
green.
neutral right
It's
now.
neutral.
But it could be because it didn't dissolve yet.
Yeah, you should have crushed it
Yeah.
with the masher.
Well, let's see if it changes. It looks like it's going a little bit yellowish right now.
Yeah, a
So
little
it would
lighter
be,
thing.
which would be pH, less than 7. Anything else you want to try?
Borax.
Okay.
From the
20
war.
milting borax. I'm not sure where this is going to be. I'm going to guess it's basic.
Borax from the Lorax.
Okay. Borax, yeah. It's sodium tetraborate. I think since it's used in laundry, most times the laundry and stuff is basic. I think I'm going to guess basic just for me, but let's find out. I have a blue. I guess it's up in here somewhere. Yeah, it's definitely basic. 7 is neutral. Yeah, we're definitely getting a rainbow here.
We got. Wait,
I
don't
think
we
that's
have all the primary colors? Red, yellow.
We'll pour a couple together to see what happens. They should neutralize each other, so maybe we can pick 2 that should end up at 7. We can do that. Yeah, and then they end up at 7 maybe. Anything else you want to try before we pour one together?
Kind of.
Bleach tends to eliminate the color, so even though it'll be basic in the beginning, it'll just fade out because the bleach will bleach it out.
If we put borax
Starch?
and hydrochloric acid.
You think starch is basic? This is just like on the laundry starch. Okay, well this is laundry starch. This is something you'd eat. Okay. And you can see it's not truly in a solution. It's more of a suspension. This is to make. I don't know if people use starch that much in laundry anymore, but
Clothes look stiff.
maybe it makes them stiff. That's right. So, if you want starch white shirt, maybe if you went to a formal affair, you might. Okay, let's see what we got. Okay.
I'm seeing blue.
Yeah, that's like an aquamarine almost. Which probably puts it about pH 9. It's about the same as same as the borax, actually. Very low.